Alright guys, we're going to look at binomial expansions. Basically, it's a shortcut for multiplying out a binomial. So for example, if you look at this binomial to the third power, 2x plus 5 to the third power, typically we would say, oh, we're going to write 2x plus 5 3 times, okay? And then we're going to need to multiply it out. So we might multiply these first two parentheses together, simplify that, and then we still have to multiply it to the third. But now I'm going to show you a shortcut. So while you're like, well, that's not too bad, what if it said 2x plus 5 to the sixth power? Okay? So let's look at some patterns that are going on here. So if you look below this, we have some examples, x plus y to the third, x plus y to the fourth, and x plus y to the fifth. It says, what pattern do you notice with the exponents? So take a second, maybe pause the video and think about that. I noticed that with my x's, my exponent starts at 3, it goes down to 2, then it's 1, and then we have no x's. Look at your y's. Your y's, there's no y. Y to the first, y to the second, y to the third. So that continues in the other two examples with this pattern. Except in those, when it's to the fourth, it starts with x to the fourth and ends with y to the fourth. Same thing with the fifth. We start with x to the fifth, we end with y to the fifth. Okay? Now we're going to see, where do these numbers come from? Where does this 1, 3, 3, 1 come from? 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. Okay? So we're going to look at what we call Pascal's triangle. Now I'm going to teach you a little bit about Pascal's triangle. So in Pascal's triangle, the triangle starts with a 1, and all the numbers at the beginning of each of these rows is 1. Same thing over here. All of these numbers at the end are 1. Now, it's going to be helpful if you switch colors, just so you can see the pattern that's going on. So this box right here, it's not a box, sorry, this hexagon. To figure out what goes there, we're going to add together the two numbers that come from above. So that's going to be 2. Let's do the same thing below. So I'm going to add the 1 and the 2, and I get 3 here and 3 here. Now we have another number we're going to introduce in this next one. So 1 and 3 is 4. 1 and 3 is 4. Notice that we have a 4 after the 1 and a 4 before that last one. Now let's look at what goes in the middle. 3 plus 3 is 6. Let's go again. This row. 1, 5. Let's figure out what's in the middle. 4 plus 6 is 10. 4 plus 6 is 10. Then we have another 5. This pattern is going to continue throughout the rest of this triangle. So why don't you hit pause and see if you guys can fill in the rest of Pascal's triangle. Okay, so here's where we end up, okay? Now let's focus on the patterns. I don't want you guys to stress out about having to fill out this entire thing. We typically don't go beyond this row here that starts with a 1 and ends in a 6. Now let's talk about some other patterns that are going on. I want you to focus on these numbers here. Notice that they're increasing by 1 each time. I didn't highlight all of them, but we can get the picture. Pascal's triangle starts at row 0. So this is row 1. Then we have row 2, row 3, and so forth. Now this row is very, very important because if you look at the problems above this, the examples with our binomial expansion, the first one is to the third power. Look at row 3. 1, 3, 3, 1. If we look up here, those are the coefficients in front of each of those xy terms. Look at row 4. 1, 4, 6, 4, 1. And it matches, the row matches the exponent that we're expanding that binomial to. That's why Pascal's triangle is very, very important. So let's come down and let's look at a worked out example together. We'll start kind of easy. So x plus 5 to the third. So let's take row 3. And color coding is going to really help you guys here. So row 3, 1. Watch how I'm going to leave a big gap. Plus 3, plus 3, plus 1. Now, we're going to start with the first term, x to the third power, the exponent on our binomial. So x to the third, x squared, x to the first, and x to the 0 power. Then we're going to look at 5, that second term. Include the sign, so it's positive 5. Now watch this. I'm going to put this in parentheses. You should really get into the habit of using parentheses here. And we'll see why that's important in some of the later examples. Now we're going to simplify each piece. So here, I really have 1 times x to the third times 1. Then we have 3 times x squared times 5. 3 times x times 25. Then we've got 1 times 125. Okay, so you can see we have 4 terms. Notice that's one more than that exponent in our x plus 5 to the third. So in this first parentheses, we just get x to the third. Here, when we multiply the 3 and the 5, we get 15x squared. Plus, simplify, 75x plus 125. That's what you would get if you were to multiply x plus 5 times x plus 5 times x plus 5 and combine like terms. Let's look at some more examples. 2x plus 3 to the fourth. Now our parentheses are going to be crucial. Row 4. 1, 4, 6, 4, 1. So remember, leave yourself a gap. Okay? Now let's go fill in using the terms in the binomial. So 2x. Look at my parentheses. 2x to the fourth. 2x to the third. 2x squared. 2x to the first. 2x to the 0. Now we take the second term and we start with 0 as the exponent and we increase. Till we end with 3 to the fourth. Now let's go through and let's simplify. So we have 2x to the fourth. Now check this out. That 2 applies, or that 4, the exponent applies to the 2 as well. So we have 1 times 16x to the fourth times 1. Over here, we have 4 times 2 to the third is 8 times x to the third times 3. Then we have 6 times 2 squared, which is 4x squared, times 3 squared, which is 9. Then we have 4 times 2x times 27. Then we have 1 times 81. So it might be helpful here to grab a calculator if you haven't already. So I'm going to bring up, ignore that background, I'm going to bring up this calculator for a second. So this first piece is pretty easy. It's 16x to the fourth. Now we're going to multiply 4 times 8 times 3, 96. So plus 96x to the third, plus 6 times 4 times 9, 216. plus 4 times 2 times 27. 216 again. 216 actually shows up a good bit when we do these expansions. And there you have it. Okay? Why don't you look at the second one, hit pause, and see if you can set it up for me. Alright guys, so this is how you should have set this up. Okay? So, let's start kind of focusing on simplifying each piece. Pause and look at this if you need to, because this negative is different. Make sure you included that in each of your pieces. So I'm going to take this piece. I have 1 times 27 x to the third times 1. Anything to the 0 power is 1. Plus 3 times 9x squared. Remember, the squared goes to the exponent on the 3 and the x times negative 1. So what's this negative going to do? It's going to change the sign on our leading coefficient for that term, or the coefficient for that piece. Okay? Not the leading coefficient, excuse me. So negative 1 squared is 1 plus 1 times negative 1. There we have it again. Okay? So let's multiply each piece. So we have 27x to the third plus, whoops, Watson, back up, minus 27x squared because of that negative. This one's all positive, so plus 9x. The back one's going to be negative. So you can see how the signs are alternating when one of those terms is negative. Okay? Now this next part is asking us to, what's the second term of the expansion? So when we write this out, we only have to focus on the second piece. We don't have to simplify everything. So let's start with the fourth row. 1, 4. Well, that's going to be my second term, so I don't really care what happens here. Now, we're going to take x to the fourth. Then we have x to the third. Okay, that's my second term. Now let's go to the negative 2y. Negative 2y to the 0. Then we have negative 2y to the first, and we can stop there. Now remember, there's going to be a plus in between there until we focus on simplifying and changing terms that we need to. So it just asked for the second term. So look here. We have 4 times x to the third times negative 2y. So our answer just says what's the second term, so we want that whole piece. Negative 8x to the third y. Okay? Now I want you to notice something here. Look at how the exponents, the 3 and the 1, they added up to 4. Just a little free side note. Next example. What is the coefficient for the xy to the third term? So we did need to expand it a little bit further. So let's come back up and let's take it further. Okay? So we have plus 6 plus 4 plus 1. Okay, so let's come back to our x's. So we have x squared, x to the first, x to the 0. Then we have negative 2y squared, negative 2y to the third, and negative 2y to the fourth. But it asks us for the xy to the third term. So looking up here, that's going to be this piece right here, our xy to the third. So let's simplify that piece. So we have 4 times x times, distribute that exponent to the negative 2's exponent and the y's exponent. We have negative 8y to the third. It just asks for the coefficient. So when we simplify this to be negative 32xy to the third, negative 32 is all we're looking for there. Okay?